Linearization is one of those things that comes up in Calc 1 that I think should be entirely skipped because it's almost just like a confusion of what you've already talked about. And since you're going to be tested on it, I'm going to cover it for you. And I think maybe the best thing to do is appreciate that since you're going to look at the same thing backward, that this could improve your overall understanding of something we already know. And it really is, I don't know, maybe it's useful sometimes. If you don't have a calculator and you're in the desert and you need to do calculus to build an arch or something, I don't know. But we can figure it out together. Let's take a look. So this is the equation they're going to give you for linearization. And they're going to say you're going to want to find tangent lines for things. That's why they use the word linear. The idea is if you have like a sine wave, and I zoom in on it close enough out here and I just have this part, and then I zoom close enough here and I've got just this part, and then I zoom in on it enough and eventually it's going to look like a straight line. If I just keep zooming in, it'll look like a straight line, and they want you to find the equation of that line. Well, we've done plenty of tangent line work, so I want to look at this equation instead, because they give you this weird, I don't know, point slope version where you see sum as a function, but then they say y equals and blibbity blob. Here's how I want you to picture this. And once you see this, all of this is going to melt away, I promise. I'm going to give you a point, and I'm going to give the x value a specific x value that we'll call a. And its y value, of course, then would be f of a, because you put in the x input and you get a y value. Now over here, rather than try and approximate the function right at its one spot, we're going to take some kind of an approximation between 2 points, just like when we found what a derivative is, when we did a slope refresher. All this is the same thing. And over here, I'm going to call this xy. This point is something apparently you get to choose. I don't know. Usually they're going to give you a, but maybe we have to do it backward. It's not going to matter. So of course, the slope of this line, which maybe, when you zoom in far enough on sine, maybe it's going like this. And this is really close to a good approximation for the equation itself right there. If I zoom in far enough on sine, if it's big enough, maybe we're looking right at this part right here, and sine looks almost exactly like a straight line here, if I could draw better. So they're saying, like, find the linearization, meaning you're not approximating the derivative. You're approximating sine itself at this exact spot using this equation. So of course, the more you zoom in, the more accurate you're going to be, right? And remember what the problem was with the definition of derivative. F prime of x equals like f of x plus h minus f of x over h. This becomes 0, and you can't divide by 0, so we just lie. And we use h until we can factor it out. In this case, we're doing kind of the same thing, but they're rewriting it in some confusing way. And what's the slope of this line? You know how to find slope. Slope is y2 minus y1 over x2 minus x1. It's just a ratio of the change in y, delta y, and the change in x, delta x. Delta means change, right? So for us, what is y2? Well, that's y itself. That's this guy. Minus y1 is f of a over x2, which is x, minus x1, which is a. And what's slope? Well, that's the derivative, so we're going to call it f prime of a. Okay, so what you have here, if I take this out now, I just want to point this out. If I multiply this up and add this over, it creates y equals f prime of a times x minus a plus f of a. That is the linearization formula right there. All they've done is rearrange the formula for slope in this form, written it in a messed up way to confuse and scare you, and then put it into y equals. So all they're asking you to do here is to think about it, y equals mx plus b, except it's not. But because you can be anywhere, you're not in an origin spot. Right, so f of a is not a y-intercept, it's like the starting spot, which you can put at the origin and make your y-intercept if you so chose. Because if you put this at 0, 0, you'll notice it's just going to become mx plus some y-intercept here. The linearization is a rewrite of slope. It's a rewrite of slope. So when you look at this, don't be confused. Don't get lost. You are just finding slope and rewriting it in that special way. And then you can plug all of this in however the question asks you to. But when you look at linearization, when you look at this insane way of describing it, for some reason they feel the need to give you another way to look at tangent lines. Just remember, this is just slope rearranged. And everything else is just there to mess with you. So make a point called AF of A, make a point called XY, and find slope, and you're going to find this formula on your own. So as we go into the problem set, keep this in mind.